Hello friends, I am back again with another session and today we are going to do the metallurgy of aluminium. Here it goes, let me share the screen and then we start with the... So here you can see metallurgy of aluminium. Now before we discuss with the metallurgy of aluminium, let me discuss what is the process of metallurgy. It is the definition says that the extraction of metal from its ore, that is known as metallurgy, that process of extraction of metals from its ore. Now the term ore, how will you define that? Your minerals, they are found within the earth crust. Now these minerals are the combined state of the elements with the earthly impurities, the gangue particles. Now all the minerals for a particular element available cannot be considered as an ore. Ore is that specific mineral for an element to be extracted from which we can extract the metal profitably or economically. That is considered to be an ore. So now in this case, if you can see here on the screen, name of the ore, it is bauxite. The formula is Al2O3.2H2O. You should be knowing that what is the chemical name and the chemical formula of the ore. That is important. Now we proceed to the second slide. Now your second slide, step 1 says washing and crushing of the ore. Now here you can see washing and crushing of the ore. Why it is required, that also you should be well aware of. So the first significance is that it removes the gangue particles, that is the impurities. Second, increases the surface area, which in turn increases the rate of reaction. Now to explain this point, I just want to tell you that if we take 2 glasses full of water of the same quantity, and in one glass we take 1 spoon of sugar crystal and we stir, and in the other glass the same sugar crystals we crush and we take it. So I think in the second glass you will find that the dissolution of the sugar will occur at the faster rate, because by crushing what you have done, you have increased the surface area. So because you have increased the surface area, therefore the rate of reaction will also increase. So here the crushing of the ore, the significance of this particular step is that it increases the surface area, which in turn increases the rate of reaction. Then comes your step 2, concentration of the ore. Now in metallurgy, children, one very important thing is that you all should be well aware with the technical terms which we are using. So concentration is nothing but it is the removal of the gangue particles by the chemical process. So now in this concentration of the ore, a name has been given to this process. It is Bayer's process, which we use in the metallurgy of aluminium. So let's see how we concentrate the aluminium ore. Your bauxite Al2O3.2H2O, it is treated with NaOH at a temperature 140 to 150 degrees centigrade. Your water molecule is getting eliminated and you are getting a soluble complex sodium aluminate, NaAlO2. Now we all are well aware of this fact that your aluminium, lead and zinc, these are amphoteric metals. Amphoteric metal means that they show both acidic and basic behavior, and the elements which are amphoteric in nature, they form a soluble complex when treated with caustic soda or your sodium hydroxide solution in excess. So finally your sodium aluminate, you can see, is again treated with water at 50 degrees centigrade. The contents are heated, you get sodium hydroxide and aluminium hydroxide. Now here you can see that aluminium hydroxide, I have used an downward arrow. You need to remember that when any product is being released in the form of a gas, you will make an upward arrow, because gases have the tendency to rise in the air. Whereas when you get a precipitate, a solid residue, it settles down at the bottom of the test tube. So we use a downward arrow. Now this aluminium hydroxide, when it is heated at 1000 degrees centigrade, you can see it changes into alumina Al2O3, aluminium oxide. Now the main purpose of the metallurgy is to convert all the ore particles into metallic oxide, because it is very easy to reduce metallic oxide, whether we use a reducing agent, whether we use an electrolytic method, but then it becomes easier. So I hope the Bayer's process, the reactions are clear to all of you. Now we see the next process. Step 3, electrolysis of alumina. This is your next step which we are talking about. Now in this step, you can see here in the diagram, the electrolytic cell is there. And in this electrolytic cell, you can see that we have taken an electrolytic mixture. And that electrolytic mixture is of alumina, cryolite, and fluorspar. Ratio is very important. The ratio is 1:3:1. That means 1 part of alumina, 3 parts of cryolite, and 1 part of fluorspar are mixed together to form the mixture. And thus the process of electrolysis occurs. The construction is in front of you in the form of diagram. You can see carbon anode and iron cathode, they are being used. Your oxygen gas at the end, because it's alumina, basically the main content Al2O3. So it will dissociate into aluminium and oxygen, your aluminium ions and oxide ions. So at cathode, we know that all the positive ions, they accumulate because cathode is the negative electrode of the electrolytic cell. So well, aluminium ions, they come and they accumulate at cathode. They gain electrons, they undergo the process of reduction and form metallic aluminium. You can see all the molten aluminium here. It is being collected in another trough. Then comes your anode. At anode, your oxide ions, they come and collect because it is the positive electrode of the electrolytic cell. Oxide ions, they lose electrons because at anode always oxidation occurs. Due to this oxidation, loss of electrons, your oxide ions change into oxygen molecules. You can see here there is an outlet through which the oxygen gas escapes out. Some part of oxygen, it reacts with the carbon anode and forms carbon dioxide because nothing is 100% complete. Some part is left unreacted, and that leftover part, oxygen, which is not able to escape, it reacts with carbon and forms carbon dioxide. Now we come to the next. Some important points to remember for Bayer's process. These points are very important because they cover the reasoning questions which come on the metallurgy of aluminium. Your first point is, like I mentioned, that your electrolyte, generally you have done recently your electrolysis for your semester 1, and you have seen that we are using a single electrolyte. But in this case, it is an exception we take in a particular ratio, your alumina, cryolite, and fluorspar. The ratio is 1:3:1. That means instead of taking a single electrolyte, we are taking a mixture of electrolyte. So there must be some purpose. When we do something out of league, there is always a significant purpose for that. So let's see. Your first point says cryolite lowers the fusion temperature. So the cryolite is mixed to lower the fusion temperature. Then fluorspar and cryolite together, they act as a solvent for the electrolyte mixture and increases the electrical conductivity, because pure alumina is almost a non-conductor of electricity. And if a component is a non-conductor of electricity, then your process of electrolysis is a difficult thing to be done. Then the next is another reasoning part which covers that a powdered coke is sprinkled over the surface of the electrolytic mixture. Why? Two purposes. It reduces the heat loss by radiation, and the second one is it prevents the burning of anode, because if oxygen will retain in the electrolytic cell, it will burn the anode. So to avoid the burning of anode, your powdered coke is sprinkled over the surface of the electrolytic mixture. Then, last but not the least, the oxygen gas evolved at anode escapes as a gas or reacts with carbon anode. The carbon anode is thus oxidized. The carbon anode is hence consumed and renewed periodically after a certain period of usage. This is again a reasoning question which comes in the exam, that why carbon anodes are changed periodically. So the reason is that the oxygen gas evolved at anode escapes as a gas. Some part left over reacts with carbon anode. So the carbon anode is thus oxidized. and the carbon anode is hence consumed and renewed periodically after a certain period of usage, because otherwise what will happen, instead of carbon anode you will get carbon dioxide, which is a gas which will escape out. And if these anodes are not changed periodically, then after some time, instead of anode you will have only an atmosphere of carbon dioxide gas. So the renewal of these carbon anodes is must. It is as similar as you change the cartilage of your water filter. We use the cartilage in the water filter in these Oros water filter. There are so many available now in the market, but then they have got a life for the cartilage. After a year or 2 years, they ask the change. The cartilage needs to be changed, otherwise it does not solve the purpose of purifying water. Similarly, here also in the metallurgy of iron, in the electrolytic cell, once this electrolytic process is being carried out, we see that after a certain period of time, carbon anode has to be replaced with the new one in order to carry the rest of the process smoothly. Please don't forget, metallurgy is an industrial process where we are aiming to extract the metal on a large scale. Then comes the last process, or you can say the last step, that is refining of aluminium. And this refining of aluminium is done by Hoops process. Now, here is the diagram. You can see molten impure aluminium is taken in the electrolytic cell. These graphite rods which are there, they act as cathode. The carbon lining which is there in the electrolytic cell, it acts as your anode. Now, this electrolytic process, when it occurs, your impure anode, you cannot say impure anode, rather impure aluminium, which we have obtained after the process of extracting it through the electrolytic reduction of alumina, it still contains some traces of impurities. So for that, this electrolytic refining of aluminium by Hoops process is mandatory to be carried out. Now in this, what happens, your impure aluminium, which is there at anode, we all know that at anode oxidation occurs, loss of electron occurs, it changes into aluminium ions. Aluminium ions, being electropositive in nature, are attracted towards the cathode because cathode is a negative electrode. At cathode, due to the process of reduction, your aluminium ions change into metallic aluminium, and this is called pure aluminium, because all the impurities, they are neutralized, they do not carry any charge, so they collect at the bottom of the electrolytic cell, which is also known as anode mud. So hence now after electrorefining, we can say that we cannot say that we obtain 100% pure aluminium, but yes, we obtain at least 98-99% pure aluminium. So this was all about the metallurgy of aluminium. I hope the things are clear. This video will be helpful for you all. Very soon we will be meeting with the next topic in chemistry. Till then, please stay tuned with Chemistry Tute. Have a nice day. Thank you.